Hello, we're back again. Thank you so much for always staying tuned. Now, we already started with Surds division and rationalization of denominator of Surds. Now, we'll talk about rationalization, meaning that you're trying to convert the denominator of a fraction that has a surd as a denominator or has a surd in the denominator. Try to make it become rational number. So what you do is to rationalize it by multiplying both the numerator and the denominator by the surd so that the denominator becomes a rational number. What are rational numbers? Whole numbers. So let's go. Now we'll have these two questions. We want to pick one, start from one first. So take this and later we'll come to this. So let's go. So starting with question number one. Now, I want you to try your hands on this before we get there. But meanwhile, if you have gained value, don't forget to subscribe or follow, share, tell your friends or tell someone that you're gaining value. You can get this video for your son or daughter who wants or who's struggling with maths. Maths is difficult, maths is simple, depending on the person, but you have. Now, one of our gifts is our ability to teach difficult math questions in such a way it becomes simple to understand, and it's something you want to leverage on by watching these videos. Please check the previous videos, watch, comment, like, subscribe, follow. Thank you. So let's pick the first one. We have the root 3 plus 1 root 3 plus 1 root 27. Now this is square root, I call the root. Now this number is the same thing as all over 1. Any number, any digit, that is A is the same thing as A divided by 1. If it is 10, 10 is the same thing as 10 divided by 1. If it is 11 or 12, it's 11 by 1. So 11 divided by 1 is still 11. 10 divided by 1 is still 10. Any number divided by 1 is still. So the same thing. This divided by, this is still the same thing as this over 1. Now, so, same thing as putting it as over 1. So this is how it is. Now, there's something you need to do. What is a rational number? Now, this one brings us back to why we have to rationalize the denominator, because the denominator contains a surd. In fact, in this case, it's actually a surd. So what we do, we have to rationalize this by making it a whole number. Make sure the denominator is a whole number. So rationalizing denominators. So what we do here is going to be root 3 over 1. This one has a whole number, so nothing on it. So we work here on this and this. So 1 over root 3. Now we'll see, how do we make this rational? By multiplying both the numerator and the denominator with the surd. And what the surd? Root 3. So root 3. So this root 3 is multiplying both the numerator and denominator. So we'll do that for this and do that for this. So for this one, we've done it here. So for this, okay, the original question has a subtraction sign, minus sign here. So this is going to be the same thing as 1 over root 27, okay, times root 27 all over root 27. Like this will rationalize the denominator. So let's go to this other place. So let's understand again. In this place now, let's go. So this is same thing as having root 3 over 1 plus 1 times root 3 is root 3 all over root 3 times root 3. Look at it. It means root 3 times root 3. Bring it together. I know the answer is 3, but let's see how it works. Let's work it out. It's the same thing as joining it together by making it 3 times 3. So what is 3 times 3? 9. So what is square root of 9? 3. So this times this will give us 3. The same thing will apply here. 1 times 27 will give us root 27. And then root 27 times root 27 will give us what? Root 27. Let's assume this is root 27 times root 27 27 times 27, this and this square root will give us what? 27. So the square root, root 3 times root 3 is the same thing as 3. Because root 3 times root 3 will give us root 9. The square root of 9 is 3. So this will automatically be 27. Now, getting to this place, we now have a rational number at the denominator. So rationalize the denominator. But we don't have to leave here. We have to simplify it because the question says simplify. It's still not as simple as it can get. So let's go on. So the next thing is to work fractions, adding or subtraction of fractions. That's what we have. The operational sign is plus and minus. So what do? We'll find the LCM of the denominators, which is the lowest common multiple. The lowest common multiple, I believe at this level, you should know how to do LCM. You've known that probably some 5-6 years ago, or let's say even 4 years ago. So the LCM of 1, 3, and 7 is the number that this number can divide, is a multiple that this one can enter into, this was will go into, and this will go into, and the lowest of it, which is LCM, the lowest number. There are more than, it can be more, there are several numbers, but 27 is the lowest number that 1 can go into, 3 can go into the number, and 27 can also go into it. So let's go. 1 into 27 is 27. 27 times root 3 is going to be 27 root 3, or 27 times root 3, let's leave it that way. Plus 3 into 27 is 9. 9 times root 3 is going to be 9 times root 3. And then 27 to 27 is 1. So 1 times 27 is going to be 1 times 27. So having this way, root 27, pardon, or 1 times just root 27. So let's go on. But there's something you need to know. What we have is essentially 9 root 3, 27 root 3. The same thing. Oh, okay, now let's go 27 root 3, 27 times 3 plus 9 root 3 is 9 root 3 minus 27. But what is 27? What is 27? 27 is the same thing as 9 times 3. So instead of leaving this as 27, let's change it as 9 times 3 all over 27. So what is it? What is 9 times 3? Let's repeat this again. What is 9 times 3? The same as saying the square root of 9 times the square root of 3. What is the square root of 9? 3. So 3 times root 3. So 3 times root 3 is what? 3 root 3. That is easy. So you come here, you say 27 root 3 plus 9 root 3 minus, this we already have as 3 root 3 all over 27. So there's something very striking making it very easy to add or subtract, or add and subtract. It's because they all have a common variable. The variables are the same. This is root 3, root 3, root 3. It is just like doing 27x plus 9x minus 3x. That is, if you take root 3, that is if root 3 now means, if root 3 now means you now represent it with x, right? So in this place down, we can say like 27x plus 9x plus 3x, right, over 27. I'm just using that example. So 27 plus 9, 27 plus 9, so 27 plus 9, 20, 29, 30, 31, 32, 33, 34, 35, 36. So you have it at 28, 29, 30, 31, 32, 33, 34, 35, 36. So we have 36 minus 3 is 33. So we have 33x over 27. But don't forget, this x actually represented root 3. So what do we go back to? We go back to it as 33 root 3 over 27. But does this finish it? I don't think so. You know why? Number can divide this and divide this, and that number is 3. 3 can divide this. So 3 can go. 3 can divide this. 3 here, 11. 3 here is 9. So our final answer got to be 11 root 3 all over 9. This is final. So you have a question you can ask. But based on this, try your hands on this. Till we'll see you in the next class. Bye for now.